ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಬ್ಯಾಕಲ್ ಆನ್ಸಾಗರ್ ಇಕ್ವೇಶನ್ ಆ್ಯಂಡ್ ಕೋಲ್ರಶ್ ಲಾ ಇದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಡಿಬ್ಯಾಕಲ್ ಆನ್ಸಾಗರ್ ಇಕ್ವೇಶನ್ ಬೇಸ್ಡ್ ಅಪಾನ್ ದಿ ಎಬೋ ಐಡಿಯಾಸ್. ಅಂದರೆ ನಾನು ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಬ್ಯಾಕಲ್ ಥಿಯರಿ ಬಗ್ಗೆ ಹೇಳಿದ್ದೀನಿ. ಡಿಬ್ಯಾಕಲ್ ಥಿಯರಿ ಫಾರ್ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಇದರಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. ಆ ಲಿಂಕ್ನ ನಾನು ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಹಾಕಿರ್ತೀನಿ, ನೀವು ನೋಡಿಲ್ಲ ಅಂದರೆ ನೋಡಿರಿ. ಬೇಸ್ಡ್ ಅಪಾನ್ ದಿ ಎಬೋ ಐಡಿಯಾಸ್, Debye-Huckel in the year 1923 derived a mathematical expression for the variation of molar conductance with concentration. This equation was further improved by Onsagar in the year 1927, and now the equation is known as Debye-Huckel Onsagar equation, or simply Onsagar equation. For univalent electrolyte, it is written in the form of lambda c is equal to lambda naught minus bracket open 82.4 divided by eta bracket open dt bracket close power 1 divided by 2 plus lambda naught into 8.20 into 10 power 5 divided by bracket open dt bracket close power 3 divided by 2 bracket close root c, where lambda c is equal to equivalent or molar conductance at concentration c. Lambda naught means equivalent or molar conductance at infinite dilution. D means dielectric constant, eta means viscosity of the medium, where T means temperature of the solution, C means concentration of the solution. It is called Debye-Huckel Onsagar equation. D and eta are constant for a particular solvent, therefore at constant temperature the above equation can be written as lambda c is equal to lambda naught minus bracket open a plus b into lambda naught bracket close root c, where a and b are constant for a particular solvent at particular temperature. It's the nature of graph root c versus molar conductance. Root c versus molar conductance. In the case of strong electrolyte itara barutte. In the case of strong electrolyte, the line is passing on the y axis. The line is passing through the y axis. This particular point is called molar conductance at infinite dilution. Itara barutte. In the case of strong electrolyte, the line is passing through the y axis. This point is called molar conductance at infinite dilution. Means in the case of strong electrolyte and dilution, it will reach limiting value. This is called limiting value. It is nothing but molar conductance at infinite dilution. In the case of weak electrolyte, the line is moving parallel to y axis. The line is moving parallel to y axis. It will not reach limiting value. Limiting value reach agala in the case of weak electrolyte. In the case of weak electrolyte and dilution, the number of ions increases. On dilution, the number of ions increases, but it will not reach limiting value. Okay, means in the case of weak electrolyte, the molar or equivalent conductance increases with increasing the dilution, because dilution causes ionization of weak electrolyte, but it does not reach the infinite or limiting value. Then what is the limitation of this Debye-Huckel Onsagar equation? By using Debye-Huckel Onsagar equation, we cannot find out molar or equivalent conductance of weak electrolyte at infinite dilution. Okay, andre ಏನು in the case of strong electrolyte on dilution ಏನಾಗುತ್ತೆ, in the case of strong electrolyte on dilution, the distance between positive negative ion increases. On dilution, the distance between positive negative ion increases and it will reach limiting value. This is called molar conductance at infinite dilution. In the case of weak electrolyte on dilution, the number of ions increases, but it will not reach limiting value. The line is moving parallel to y axis. The line is moving parallel to y axis. Therefore, we cannot find out molar conductance of weak electrolyte at infinite dilution by using Debye-Huckel Onsagar equation. It's the limitation of Debye-Huckel Onsagar equation. By using this equation, we can find out molar or equivalent conductance of strong electrolyte at infinite dilution. But by using this equation we cannot find out molar or equivalent contents at infinite dilution in the case of weak electrolyte. It's a drawback. Okay, next, the next one is Kohlrausch law. At infinite dilution the dissociation of the electrolyte is complete and hence each ion makes a definite contribution to the molar conductance of electrolyte irrespective of nature of other ions associated with it. Okay, the definition is, according to Kohlrausch law, the molar conductance of any electrolyte at infinite dilution is the sum of molar conductance of its cation and anion at infinite dilution is called Kohlrausch law. Kohlrausch law ಅಂದ್ರೆ ಏನು? The molar contents of any electrolyte at infinite dilution is the sum of molar conductance of its cation and anion at infinite dilution is called Kohlrausch law. For example, see, the molar conductance of acetic acid at infinite dilution, the molar conductance of acetic acid at infinite dilution, that is equal to molar conductance of its anion. In this case the negative ion is CH3CO minus at infinite dilution plus the molar contents of cation. In this case the cation is H plus. Okay, the molar contents of cation at infinite dilution is called Kohlrausch law. Okay, andre ಏನು? According to Kohlrausch law, the molar contents of any electrolyte at infinite dilution is the sum of molar contents of its cation and anion at infinite dilution is called Kohlrausch law. Applications of Kohlrausch law. The first one is calculation of molar contents of weak electrolyte at infinite dilution. Okay, calculation of molar contents of weak electrolyte at infinite dilution. By using Debye-Huckel Onsagar equation we cannot find out molar contents of weak electrolyte at infinite dilution, but by using Kohlrausch law we can find out the molar contents of weak electrolyte at infinite dilution. Okay, molar contents of weak electrolyte at infinite dilution cannot be determined experimentally, but this can be calculated by using Kohlrausch law. The molar contents of acetic acid at infinite dilution can be calculated by knowing the molar contents of KCl, HCl and potassium acetate at infinite dilution. ಅಂದ್ರೆ ಅರ್ಥ ಏನು? molar contents of acetic acid at infinite dilution ಕಂಡುಹಿಡಿಯಬಹುದು. If you know the molar contents of KCl, HCl, potassium acetate at infinite dilution, ಈ ಮೂರದು ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದ್ರೆ molar contents value at infinite dilution we can find out the molar contents of acetic acid at infinite dilution. That is, apply Kohlrausch law for acetic acid. The molar contents of acetic acid at infinite dilution, that is equal to molar contents of acetate ion at infinite dilution plus molar contents of H plus ion at infinite dilution, cation plus anion. Okay, similarly apply Kohlrausch law for KCl, HCl and potassium acetate. Apply Kohlrausch law for KCl. The molar contents of KCl at infinite dilution, that is equal to molar contents of its cation. In this case the cation is K plus ion, therefore the molar contents of K plus ion at infinite dilution plus molar conductance of anion. In this case the anion is Cl minus ion. The molar contents of Cl minus ion at infinite dilution. Next, for HCl, the molar contents of HCl at infinite dilution, that is equal to molar contents of H plus ion at infinite dilution plus molar contents of Cl minus ion at infinite dilution. Similarly for potassium acetate, the molar contents of potassium acetate at infinite dilution, that is equal to molar contents of acetate ion, that is negative ion CH3CO O minus at infinite dilution plus the molar contents of K plus ion at infinite dilution. ಅಂದ್ರೆ ಈ ಮೂರದು ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದ್ರೆ we can find out the molar contents of acetic acid at infinite dilution. Next, ಹೆಂಗೆ? The molar contents of acetic acid at infinite dilution, that is equal to molar contents of potassium acetate at infinite dilution plus molar contents of HCl at infinite solution minus molar contents of KCl at infinite solution. Andre ಏನು, we can find out the molar contents of acetic acid at infinite solution by using this one, that is molar contents of potassium acetate at infinite solution plus molar contents of HCl at infinite solution. ಅಂದ್ರೆ potassium acetate HCl molar contents ನ ವ್ಯಾಲ್ಯೂನ ಆಡ್ ಮಾಡಬೇಕು. ನೆಕ್ಸ್ಟ್ ಮೈನಸ್ ಮಾಡಬೇಕು ಯಾವುದನ್ನ, molar contents of KCl at infinite solution. potassium acetate HCl ವ್ಯಾಲ್ಯೂನ ಆಡ್ ಮಾಡಬೇಕು, KCl ವ್ಯಾಲ್ಯೂನ ಮೈನಸ್ ಮಾಡಬೇಕು. that gives molar contents of acetic acid at infinite solution. Okay, next calculation of degree of dissociation of weak electrolyte. By using Kohlrausch law we can find out degree of dissociation of weak electrolyte by using formula, that is alpha is equal to molar contents at specific concentration divided by molar contents at infinite solution. Okay, ಇದೆರಡರ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದ್ರೆ we can find out degree of dissociation of weak electrolyte, that is alpha is equal to molar contents at specific concentration divided by molar contents at infinite solution. ಇದೆರಡರ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದ್ರೆ that ratio gives degree of dissociation of weak electrolyte. Next, more application, calculation of solubility of sparingly soluble salt. Calculation of solubility of sparingly soluble salt. Salt such as HCl, BaSO4, PbSO4 etc., which dissolve to a very small extent in water are called sparingly soluble salt. Sparingly soluble salt ಅಂದ್ರೆ ಏನು, ಅದರ solubility ಕಡಿಮೆ ಇರುತ್ತೆ ವಾಟರ್ ಅಲ್ಲಿ, therefore we are calling as a sparingly soluble salt. Their solubility is less in the water system, we are calling as a sparingly soluble salt. Now solubility can be obtained by the equation, that is solubility is equal to K into 1000 divided by molar contents at infinite solution. Okay, solubility is equal to K into 1000 divided by molar contents at infinite solution. 1000 constant, K ಅಂದ್ರೆ ಏನು, K is nothing but specific contents. Next ಇದಂದ್ರೆ ಏನು, lambda m not means molar contents at infinite solution. Andre if you know the value of K and molar contents at infinite solution, then we can calculate solubility of sparingly soluble salt by using this equation, that is solubility is equal to K into 1000 divided by molar contents at infinite solution. Thank you.